So good morning, everyone. How's everyone today?
Good.
Good. We are excited to see such a wonderful crowd here. My name is Jessica, and I work at the Great River Road Visitor and Learning Center at Freedom Park. I want to say a few really quick thank yous before we get started and before I turn it over to Jennifer. I want to say thank you to the Prescott Public Library and City Hall for allowing us to have this program here. We can't fit quite as many people in our multi-purpose room at the Great River Road Visitor and Learning Center at Freedom Park as we can in this room, and we're lucky to have the space today. So thank you to everybody for sharing this program too. We did a lot of work to make sure it got into the papers, onto Facebook, and my apologies for those of you that went to our visitor center instead of coming here. We thought it might be a little tricky to make sure we get everybody here, so we might still have a few people filtering in. We have quite a number of environmental education programs that happen at our visitor center, and we team up with the Prescott Library and Prescott Community Television every opportunity we get. So thanks to everybody. Thanks to Larry for videotaping this program. Hi, Landon. Thanks to Landon for coming here. So I'm going to introduce now Jennifer Redell, who is a bat biologist with the Wisconsin DNR. She came a great distance, and we are just very lucky to have her here and her expertise here to help us all understand better how we can support our native bats in Wisconsin and beyond. There's a lot of work that we can do just in terms of educating ourselves, and then also, maybe changing a few of our habits up a little bit to support our native bat populations. So thank you all for being here. I'll turn it over to Jennifer Redell.
Thank you, Jessica. Hi, everybody. I'm going to turn some lights down and make it a little bit darker. Oh, I thought I was. So that you guys have an easier time seeing the screen. And welcome. And we're here to celebrate bats today and hopefully learn a few new things. To start out, I took this video with my cell phone at a certain time of the day. Anybody know what time of the day I would have taken the video? What do you think? At nighttime? Is that what you were going to say? Yeah. So we know that bats come out at night, right? They come out when it's dark, so we call those animals nocturnal, right? And this is kind of a trick question because I actually took this video not at the beginning of nighttime, but at the end. So just before the sun rises in the morning, you're looking at a group of bat houses silhouetted in this image. And bat houses are homes for bats, right? Just like we can build bird houses, we can also build bat houses. This is an example of one, and we'll talk more about that as we go today. But bats sleep in the bat house during the day. As the sun sets, they wait about 30 minutes, and then they emerge. They drop out of the bat house, and they fly off, and they leave the area almost right away. Then they're out foraging all night long. They're eating insects in the dark of night. But about 45 minutes before the sun rises in the morning, they come back, and they get ready to go to sleep for the day. So this is video taken just before sunrise back at the bat house. And the behavior that you see is a little bit unusual. It's behavior that most of you won't experience unless you're willing to get up really early near a bat colony. This is called swarming. And this is the same type of behavior we see when bats come into hibernation. They go to their cave or their mine in the fall, and they swarm around the cave or mine entrance. So it's a wonderful way to experience bats. You get to see them in close proximity, and they'll even fly all around you if you're willing to get up early and if you know of a bat roost. Yeah? Yeah, so I've got part of the video in slow-mo, and then you'll see it speed up. It's just been looping here as we go. So I'm Jennifer Redell. I'm a bat biologist. I study bats for a living, and I work out of the Madison Central DNR office. I work with two other bat biologists, and we cover the state of Wisconsin. We work with lots of other folks, and I'm going to tell you a little bit about the work that we do today. But to give you a preview of our program, I like to get everybody on the same page first. So first we're going to all learn some basic things about bats in case you didn't know already. We'll talk specifically about Wisconsin bats and how we study our Wisconsin bats. And then I want to tell you about some threats that they're facing. The number one threat is white nose syndrome. And then at the very end is when I'll bring out live bats. okay? So the bats are mammals, they're not birds. And I always like to let people know with the big fruit bat that I bring out, it's a little bit like bringing your cat out to the library. So it's not always predictable. He's used to being around folks, but there's some behaviors that we can do to make him feel safe and comfortable when I bring him out. So we'll talk about that as we go through the program today, but to start out, we'll kind of do this crash course in bats. Bats are amazing animals, okay? But they are a group of animals that traditionally have been misunderstood, right? And so therefore they've been underfunded and understudied. They're also non-game species. It's opening gun deer season today. These are not animals we can hunt, so we don't see a lot of revenue from hunting. There's not a lot of interest in them traditionally out there in the world. So when that happens, when a group of animals is understudied and then they face a threat like our bats are now facing, that puts us at a disadvantage. But incredible animals, most of us already know that they're important. So this is a picture of a cave in Texas called Bracken Cave. It's owned by a group called Bat Conservation International, and it's unique because it's home to the largest group of mammals in any one spot in the world. So there are Mexican free-tailed bats that reside in the cave, and it's not just any cave, it's a special colony, it's a maternity colony. So this group of bats are mother bats giving birth to their babies inside the cave, and there are 20 million of them that roost here. So at night, when they leave the cave and start eating their insect prey, they literally eat tons of insects, okay? And then they return to the cave in the morning. And so this is a site where you can pay. It's a fundraiser, but you can go watch the emergence, and it's one of the most spectacular wildlife phenomena that you can see in the world. So we know bats are important because they're eating insects, right? And that helps us out. In various parts of the world, they're important for spreading the seeds of plants. They're important for pollinating certain plants. And if you like to get bananas and avocados and papayas and figs and cashews and chocolate at the grocery store, you're buying products that at some point and somewhere in the world are being benefited by bats, either through seed dispersal or pollination. And for the adults in here that enjoy the occasional margarita, bats are the primary pollinator of agave plants. So that's where we get tequila from, right? So no bats, no tequila. And that's really important to remember. Yeah. Bats are mammals, okay? They're the only truly flying mammals. And they belong to their own scientific order. They have their own group, okay? It's called Chiroptera, and it means hand wing. So if you look at your hand, and you can hold out your hand, you've got a thumb, right? One thumb, and then you have 4 fingers, right? And if we look at a bat's wing, a bat has a thumb and 4 long fingers. So the only difference between your hand, the skeleton that's in your hand, and the bat's wing is that the proportions are different. So you'd have to stretch your fingers all the way down to the ground, and your fingertips would kind of drag around on the floor as you walked, in order to have bat hands. But they really do have hands, and they've of course got this flexible skin membrane stretched between the fingers, and that's what makes them have a wing and they can fly. If you want to know what a bat wing feels like, I can't let you touch the bats that I brought with me today, but their skin on their wing feels exactly like your eyelid. So if you gently touch your eyelid, it's kind of stretchy and soft skin. That's just what a bat wing is like. So when we watch bats fly, we can watch them use their wings for flapping and flying. But you'll notice this bat's hunting moths, and it's using its wings not just for flapping and flying. So it's sort of reaching out, right? Reaching out and grabbing the insect and bringing it to its mouth, just like you might reach out and you'd grab a piece of fruit, an apple or something, and bring it to your mouth. And bats have a membrane between their legs, their hind legs too, and that allows them to sort of scoop up insects as they approach and hunt. And I can hear just a little bit of echolocating happening in the background, so this bat is using sound to help it hunt. So if we look at bats around the world, this whole group of animals that are bats, they all have some things in common. They're all nocturnal. They all hang upside down. They've got a special little tendon in their hind feet, and it lets their toes kind of grip onto things so that they can even sleep hanging upside down. They don't have to think about it to keep their toes gripping. Some, but not all of them, use sound or echolocation to hunt. And worldwide, they've got really diverse diets. So most of us are familiar with the fruit-eating bats, the nectar-feeding bats. This is a bat that has a tongue 1.5 times its body length. So if that were me, my tongue would be 9 feet long. Really weird, right? But just to get at the nectar at the base of a flower, there are bats that fish for their food. So this is a species that, just like an eagle would do, gaps the fish out of the water. There are bats that eat frogs and birds and mice and other bats. This is a rainforest bat. And if you're thinking about hunting frogs in the rainforest and you're going to eat rainforest frogs, is that a good idea or a bad idea to eat just any frog that you find in the rainforest? What do you think? You're giving me thumbs down. Like, no. Some frogs in the rainforest are poisonous, right? And what's nature's warning sign for the poisonous frogs? You can shout it out if you know it.
Colors?
Bright colors, yeah, bright colors. So those poisonous frogs have bright colors. The bat is hunting in the dark at night. It can't see the bright colors, but it does know how to do something. It listens, and it can tell the difference between the different frogs' calls. Okay, so it knows which are the safe ones to hunt. We've got bats that are immune to the stings of the scorpions and the centipedes they eat. This is the pallid bat. And then, of course, people are familiar with vampires. There's 3 different species of vampire bats. These are the sanguivores, or the blood feeders. And they all live in Central and South America, although their range is expanding northward, so we're expecting them in Texas in the near future. They do not suck blood, okay? They do, however, land on the ground next to their prey, or they'll land on the prey animal itself, which is usually a cow or maybe a goat. And with those 2 little sharp teeth at the top of their mouth, they make a little incision in the skin, and then with their tongue, they lap up about a teaspoon's worth of blood, and then they fly away. Okay, so the animal doesn't bleed to death, and it doesn't turn into a vampire cow the next day, nothing like that. But these guys have really interesting social structures, really interesting social behaviors, and they're very prone to starvation. So they are actually known to share a blood meal with their roost mates, their unrelated roost mates back at the roost if those roost mates were unable to feed at night in order to help them survive. So that's what you're seeing here is food sharing. Nothing says love like throwing up blood in your friend's mouth. All right, so bats are part of the food chain. So around here, we've got some predators that eat bats. This is a Cooper's hawk outside of one of the Crystal Cave entrances near Eau Claire, but snakes, owls, hawks, raccoons are all bat predators. Of course, we have to be careful if we let our cats outside. They'll predate on our native songbirds and on bats as well. And because bats sleep during the bright daytime, and because for the most part they are really tiny, they are really vulnerable. And they do get eaten by other animals, and they are afraid of large animals like you. So that's why if you find a bat, it might try to scare you, right? It might put its wings out and bare its teeth and make a lot of noise because it's really very afraid of you. But they like to stay hidden during the daytime. In the wild, they'd go under tree bark, right? Some loose tree bark, or into the crack or crevice in the trunk of a tree or a branch. We accidentally, will mimic those conditions with loose barn boards and attics with little openings in them. Or we might put 2 boards close together and make a bat house, an intentional home for bats. And so that's what I've got here. And we'll talk more about bat houses as we go today. But you can see this really thin space. Bat house is really narrow. And the bats land on the bottom, and then they crawl up. There's an opening here at the bottom that the bats crawl up into. Okay, so they go right up inside of here. And if we then put that up in an area where it's warm and it'll get lots of sun, that mimics natural tree bark. So Bats are susceptible to decline for a number of reasons. They are animals that are social, so they like to gather together in large numbers during really very critical phases in their annual cycle. You're seeing a picture here of a cave in Tennessee, and this is a cave called Hubbard's Cave. These are gray bats. There's literally tens of thousands of bats in this big, massive cluster. The biologists are doing their winter hibernation survey. These bats spent the summer over thousands of square miles of landscape, scattered over people's neighborhoods and farms and forests. And then every year they come to just this one wall, in this one cave. So if something happens like the cave floods, or if the ceiling collapses, or if there's a disease, it can very quickly kill off a huge number of bats that then don't come out of the cave and scatter across the summer landscape. So they're reliant on these critical habitats like caves. They're slow to reproduce. Each mother bat just has one baby, one pup per year. And so if a population decline occurs, it's really hard for that population to grow back, to recover. Bats live everywhere in the world except the North and the South Poles, okay? And there are over 1,200 different species. So that means out of all of the mammal species on Earth, bats make up about 20% of our mammal diversity on the planet. I mean, that's incredible. 20% of our mammals are bats. Incredible. Worldwide, they fall into two broad categories. And so the bats of Africa, Asia, and Australia are the big mega bats. Okay, here's my friend Rob. He's holding the largest bat species in the world. That's a Malayan Flying Fox. I don't have a Malayan Flying Fox with me today. But I do have a cutout. They've got a 6-foot wingspan, okay? So that's about as tall as I am, right? About my arm span then, if I hold this out. So luckily, they eat fruit. You know, not pets or small children or anything. So the fruit bats are the old world bats. Typically, they don't use echolocation. But then everywhere in the world, we've got these little guys, the microbats, and most bats are microbats. And so you'll be meeting an example of each today. So here in Wisconsin, all of our bats are little. We've got 8 different species. And our bats are all insectivorous. They're the primary predator of our night-flying insects, and they're really hungry for those insects. So a single little brown bat can eat up to 1,000 mosquito-sized insects in just 1 hour when she's out hunting at night. She'll eat up to her body weight in insects if she's a nursing mom. Okay, so that's like a person who weighs 100 pounds going out and eating 400 quarter-pound cheeseburgers in one night if you wanted to eat your body weight. Okay, and you'd have to do that again the next night, and the night after that, the night after that. That means bats are valuable, not just as human pest control with mosquitoes, but our farmers and agriculturalists rely on them for natural pest control. So they're eating corn borer moth, cutworm moth, potato beetles, grasshoppers, and saving our farmers to the tune of $658 million to $1.5 billion in pesticide costs each year. And just to go back to mosquitoes for a moment, there's a researcher at UW-Madison who just published some data looking at bat diets. Our Wisconsin bats aren't just eating any mosquitoes, they're eating up to 17 different types of mosquitoes, okay? I didn't even know we had 17 kinds of mosquitoes, did you? That's a lot. So these are the bats of Wisconsin, and this is your challenge. Most of you can probably name 8 different bird species that you'd see locally, but your challenge is to learn your 8 native bat species, okay? The group across the top of the screen are known as tree bats. These are the migratory bats. So just like some birds, they'll go somewhere warmer in the winter. And then the bats across the bottom of the screen are the hibernators, and they are the only bats that will seek out a cave or a mine. And when it gets cold out, they'll go down into that cave to hibernate. So I'll spend a little time introducing you to the more common bats that you might encounter. The 2 most common bats in North America are the little brown and the big brown. And if any of you have a bat story it involves very likely one of these two species. If you had a bat actually get into your living space, it was probably a big brown bat, particularly if it was fall or winter. Now, I'm a bat biologist, and when these guys are flying around at night, when we watch them emerge after sunset, and a bat flies by, I cannot tell you what species just flew by. Okay, we can't identify them just by visually looking at them. They're tiny, they fly fast, it's dark out, and that's one of the things that makes bats hard to study. But they are producing sound, right? So just like you could go out into the forest and you could listen for different bird species, and you don't have to see them to identify who's there, we can listen in on the bat's echolocation calls with the help of this little device called a bat detector, and that helps us identify species. So when the bats are echolocating, they're sending out constant sound. The sound bounces off of an object, comes back as an echo, and they listen, and then they navigate that way. This will pick up the ultra high frequency noise that they're producing. Our ears can't hear it, but this can. So if I turn this on, and I'm going to ask you guys kind of in the front row to help me, if you can rub your hands together really fast, like you're warming them up, you're going to produce ultrasound. Good echolocating. Okay, thank you. So that's how it works. It's picking up that ultrasonic noise, the high frequency noise, and translating it down to a level that our ears can hear. So I've pre-recorded some bat calls that we can listen to. So I'll play the two different bats that we have here. We'll start with the little brown. I've got to walk back here to do this. And this is what a little brown bat sounds like. Okay, this time I'm going to play that call once more, and I want you to listen for something specific. So this is like bat interpretation or translation. When bats are out hunting and they notice an insect off in the distance, they start to track down or pursue that insect before they grab it out of the air. And in order to do that, they send out really rapid calls. So the calls get really quick and close together, and it sounds like a zipper noise, zipping up. We call it a feeding buzz. So this time, listen for the feeding buzz. I think you'll hear two of them here. Okay. So when we're doing bat surveys, we get really excited when we hear those feeding buzzes because it means a mosquito just got murdered, and that's good for us. The big brown bat is going to sound different, so here's what a big brown sounds like. Okay, so these two are hibernators. Okay, right now they're underground. In the summertime, they're up at the surface using bat houses, or maybe your attic or behind your shutters. The other two hibernating species we have are probably bats that you'll never encounter. It's getting very, very increasingly rare for me to encounter these two species because of the devastation of white nose syndrome. So the eastern pipistrelle and northern long-eared. Eastern pipistrelles are our smallest bat. They're kind of a tawny blonde color. And these are all four state-threatened species. The northern long-eared bat is now a federally threatened species as well. So the other group, the tree bats, are the migratory bats, and these bats will leave the state or at least go somewhere warmer to spend the winter. Hoary bats will go as far south as the Gulf of Mexico. And if we look at them in general, they're fairly brightly colored compared to the cave bats. We find them roosting all by themselves in trees, hiding amongst leaves or hiding on the bark of a tree in the summertime. And so they need to blend in. So I'm going to play you some of the calls that we have here. We'll start with the silver-haired bat. Okay, and then eastern red is next. So some people think those two kind of sound the same, pretty similar. The hoary bat, that large hoary bat that looks like a pine cone, it roosts in coniferous trees, is our lowest frequency bat, and you'll hear that in the call. Okay, so those noises are happening all around us when we see bats flying at night, but they're too high frequency for our ears to hear. So using bat detectors is just one way that we study bats in Wisconsin. Bats are difficult to study. Our program works out of Madison, but as I said, we cover the state. We work with lots of partners, both at other agencies and also at universities and with various research groups to study our bats and monitor what's happening with their population. We also involve hundreds of volunteers that help us collect data on bats around the state. So the most important thing you need to know about what we do is that we're trying to keep bats healthy for as long as we can, to keep as many of them around as we can in the state. And if you're interested in reading in detail about any of the information or work that I share with you today, just go on our website and search bats, and you'll find your way to our newsletter, and you can read in depth about our bat work there as well. So our work tracks the life of the bat throughout the year, and the bats really kind of determine our field schedule. So if you're a bat living in Wisconsin, most of your year, every year, is spent underground in a cave or a mine if you're a hibernator. So bats are spending 6 or 7 months of each year underground, and that's a time when they're not eating. So that's like going to your kitchen and finding the cupboards and the refrigerator bare for 6 or 7 months, nothing to eat. So they conserve energy in hibernation. In the spring, they come up out of the cave, they emerge, they come back to our bat houses, our barns, attics, and forests. They give birth to their pup around June 1st. All the mothers are gathered together at a bat house. And then the pups aren't big enough to fly. Those little babies can't fly until about July 15th, midsummer. And then everybody's out foraging, eating insects, packing on the grams. That's what you pack on if you're a bat, not pounds, but you pack on the grams. And then already by the time the school year is starting, bats have gone back to their cave or their mine. Okay, so at the end of August, bats are already journeying back to the place where they're going to spend the winter, and it all starts all over again. So in the summertime, when the bats are up on the landscape and they're sleeping in bat houses or trees, they're foraging at night, and so our work begins at sunset. And we're often doing things like setting up a mist net, or maybe another type of trap called a harp trap to capture bats in flight. Now, ideally, we don't want to handle bats. We don't want to disturb or stress wildlife. Sometimes it's inevitable. So mist netting, the net is stretched across 2 poles, and yes, the bats can see it, and they echolocate and can sense it that way. So we sort of have to trick bats into the net. We'll use a closed forest canopy on a logging road, for example. Bats fly in, they get tangled, and then we can untangle them. It doesn't hurt them. And the harp trap is a little bit like the musical instrument, a harp. It's got these parallel sets of fishing line, and the bats come out of a mine. In this case, they bump into the strings, and then they'll flutter down to this little bag at the bottom, and we can walk over and pick them up. Okay, so once we have a bat in our hand, just like when you go to the doctor, it gets a checkup. Okay, so we take weights and measurements. We might take a little sample of blood or skin or hair or guano. And the bat always gets a band. Okay, so we always mark the individual, just like birds will get banded. And this little band, in this case, instead of going over the leg, goes over the wrist, the forearm of the bat. And we hope that we'll, see that bat again after it gets released. We want to find out where it has traveled on the landscape. And bands also help us age a bat. I can't tell how old a bat is just by looking at it. I can't ask it. So this little brown bat in this photo, we took the photo in 2016 on a mine survey. And that's an individual that we find periodically. He was hibernating on the ceiling, took him down, read the band number, put him back, and checked our records. And at the time, he was banded 34 years before that as an adult. Okay, so for being really tiny animals, bats can live a really long time. Okay, 35 years is the world record. That's a Canadian little brown bat. So, you know, I figure Wisconsin, come on, we can beat the Canadian record. Come on, little bat. We often will put a little radio transmitter on some of our females. We want to learn about where they're roosting. So this tiny little transmitter gets glued to their fur. It falls off after about 2 weeks. And with this little antenna, we release the bat and she sends out a signal. And we can follow her during the daytime then to the tree where she's sleeping. So then we can count how many bats emerge from that tree. We know how big the colony is. We know if they're reproducing successfully or not. And we learn about what tree species and what habitats are important. So particularly for northern long-eared bats that are now federally listed, we want to understand habitat needs. And then that helps inform things like transmission line placement, wind farm placement, timber harvest, etc. We use technology quite a bit, as I mentioned, to try to avoid direct disturbance. So thermal cameras really help us out. And you're looking at a forest here, so there's the warm trunks of the trees, and you're kind of looking up at the forest canopy. And I'm just going to fast forward this video about a minute and a half. This is about 30 minutes after sunset in the summer. And we've got bats roosting under the bark of a tree, and the thermal camera really helps us see them against the dark forest canopy as they emerge. I'll go a few more seconds. Okay. So technology helps us out, and then we're able to not have to be present to monitor this tree. We can get a really accurate count. We can go back and review the emergence. In this case, we had 15 northern long-eared bat females coming out of this tree roost just under the bark. So technology helps us out. We'll use infrared cameras as well. We do train volunteers to use some of our technology, so the bat detectors are fairly easy to operate. This is kind of the old floppy disk version. They're a little bit newer at this point, the ones that we're actually using for research, where it's basically down to the push of a button. And you can go out as a volunteer and run a survey for us. So it involves hiking around at night or paddling around in a canoe after sunset and enjoying everything that comes along with that, in addition to listening to bat calls. So the data that volunteers collect, the recorded bat calls, comes back to us looking like this. So instead of listening to the bat calls, we're actually looking at pictures of the sound and looking at the different sound waves that the bat is producing, and then that's what helps us to identify species. Okay. The little unit also has GPS on it, so we get an idea of relative activity on the landscape. This is a canoe acoustic survey where we just canoed around a lake at Governor Dodge State Park and recorded all of these bats. So all of the different colorful dots are different bat species. And we can see relative abundance. The most common or abundant species is the little brown bat. Those are the green dots. But we've got pretty good diversity. There's a number of species on this survey, right? Locally, just to the north of us here in Prescott and along this St. Croix River, this is a survey from 2010. This is July. The brown dots are big brown bats, so you've got those locally. The green dots, again, are little brown bats. And then where you see those white dots with the X, that's a group of bats. We can't break it down to species level necessarily, but it could be an eastern pipistrelle, it could be an eastern red bat. Here's another survey not far from here. This one's from 2013. Again, lots of big browns, lots of little browns flying around in your local area. And then this survey is the same survey, but from last summer. And you'll notice that the green dots are missing, except for just a couple down at the end of the survey. Most of the green dots have disappeared. So the little brown bats are really disappearing from the landscape at this point, and that's due to white nose syndrome. So the other way that folks help us monitor bats in the state is to count and report bat roosts, or report and count. So people sit outside their bat house or their attic full of bats, and they just count the bats as they come out. It takes about 20 minutes on a summer evening. And it helps us understand what's going on with reproduction, because bats are giving birth to their pups inside a bat house. So for the folks that count bats at the beginning of summer, we're seeing just the moms fly out. And then again at the end of July, if we count again, now the pups have joined them and are flying as well. So we have about 100 different volunteer roost counts that happen around the state. And because Paul and Heather and I can't be everywhere watching every bat and every roost on a summer night, we really rely on volunteers to help us collect this data. It's really critically important. So that was summer work, and in the winter things really changed for us because the bats have gone underground. So we have the second field season that involves going underneath the surface into caves and mines. Our natural caves and our mines both collect primarily little brown bats, but ultimately all 4 of the hibernating species. So here are some little browns. They like to snuggle, they like to cuddle. They're social, and it's warm in a cluster. So we often find little brown bats in clusters, but the eastern pipistrelles, for example, will hibernate often all by themselves. They're solitary. We have about 150 different hibernation sites around the state. Most are here in the driftless area and the southwest part of the state in particular, but also some sites in Door County. Okay. Most of those are natural caves. The rest would be mines and tunnels and similar underground structures. Now, interestingly, most of our bats, 90+% of our little brown bats, are hibernating in just 3 different mines. So most of our eggs are in just 3 baskets. Okay. When we go in to conduct hibernation surveys, we're literally counting bats. We're identifying what species are there, and then we're trying to understand trends for the site. So this is an example of one of the frac sand mines that's active near here in Pierce County. And there's about 25 miles of passageway that we go through in each of these mines with bats hanging in clusters on the ceiling. It's not easy to find bats. It's not always as obvious as we see them hanging out in the mines. So most of our natural caves are really small. They've got lots of little narrow spaces. They're really wet and muddy. And the bats can fit into places where it's hard for a human to access. We have some sites where we use ropes to rappel in and climb out. And here it's a little bit hard to tell, but I'm in a raft floating around in a mine, so paddling and surveying underground. And we're looking for things like this. The bat's little nose and ears, just their little face will be peeking out of a crack in the rock, and that might be 30 or 40 feet up on the ceiling, and we're in pitch black, and we just have the light from our helmet, right, to see that. So a lot of the work that we do in the winter involves research on the disease white nose syndrome. And to finish up here with our last section, our bats are definitely under threat. And when we look worldwide at bats as a group of animals, there's lots of reasons that bats are threatened. But here in North America, white nose syndrome is far and away the thing that we're most concerned about at the moment. And so if you're interested in learning in great detail about this disease, or reading the latest updates or research or seeing maps, whitenosesyndrome.org is the website to visit for that information. But basically, this is a wildlife disease, and it mimics human diseases. And anytime we have a disease, there's always these 3 components, okay? So there's always the thing that gets sick, and in this case it's bats. It's any bats that hibernate, okay? The pathogen is the thing that causes the disease. And in this case, it's not a virus, not a bacteria, it's a fungus. And it's a fungus that loves cold conditions. Now, it's really important to pay attention to cold conditions, because when bats hibernate in a cave or a mine, they're seeking out the nice cool temperature of the underground in order to hibernate, and that's the only place where they can get sick. So bats are not getting sick in bat houses or in trees during the summer months. They can't get sick in your attic, but only when they hibernate. So when the bat is hibernating, it cools down its body to match or nearly match ambient temperature of the cave. That's about 50 degrees Fahrenheit. The pathogen, this fungus that's growing on the bats, or the mold that's growing on the bats, loves cold temperatures. And the cave environment is like a natural refrigerator underground. It stays cool every day of the year, right about 50 degrees Fahrenheit. And that's kind of the perfect storm of conditions. So what we see are bats that are diseased, have mold growing on their skin, and not just around their nose like the name implies, but it's on all of their skin tissue. So when we stretch out a bat's wing and look at it under an ultraviolet light, this is a diagnostic tool we use, we can see all of the places where the fungus, where the mold is actually eating into the bat's skin. And it's showing up as kind of yellow-orange dots. And that causes tears and holes in the bat's wing. And we saw that the wings are not just critical for flying. The bat's actually using their wings for a lot of different things, but they're critically important for gas exchange, moisture balance, and thermoregulation too. That big area of skin is helping keep the bat warm. So once a bat is sick and we see all of the skin damage, we also know that the bat's burning through a lot of fat reserves. They start waking up every 2 or 3 days out of hibernation. They can't stay in hibernation, conserving energy. So instead, every time they warm their body up, they're burning through lots and lots of stored fat. And they can't make it through till the end of winter. So bats are either starving to death or they're flying out on the landscape. They come out close to the cave entrance and they freeze to death there, or they go out on the landscape and are picked off by predators or starve or freeze on the landscape. So unfortunately, this fungus that's causing the disease is an invasive species brought from Europe or Asia. It's only affecting hibernating bats, but that's still really concerning because half of our 47 bat species in North America are hibernators. Okay? And it's killed millions of bats already. When the disease reaches a cave, within 3 years it kills off 95 to 99% of the little brown bats that it encounters, and other species as well. So here in Wisconsin, white nose syndrome got to us in 2014. That's the first time we saw it show up. Since then, it has spread to all of our hibernation sites. And depending on the stage of the disease, that 3-year progression or 3-year die-off determines kind of how far the population has declined. But in the sites where the disease has run its full course, we're down 92 or 99%, which is what we've unfortunately been expecting. Our largest sites are down, and this is at the end of, near the end of last winter, not quite to the end of the winter, but we're already down into the 70% mark. So you are noticing that on the landscape if you pay attention to bats, if you like to watch them. Here's an example of one of those acoustic surveys from a lake in Vilas County. This is 2012, so lots of bat activity, tons of dots all around the lake. All of those are different bat calls. And then this is the same survey last summer. So we're down to 1 bat on that lake on this night. It was a big brown bat, so the little browns are gone. All of the counties where we have caves and mines in Wisconsin are infected, so you can assume that anywhere you go underground in Wisconsin, you're walking into a white nose syndrome contaminated environment. The disease can affect you, can affect people, and it doesn't affect other animals, but you could accidentally pick up some of the fungus, some of the mold, and transfer it to another location. So here's where the disease is in North America. It all started in New York State in 2006, 2007. Okay, so a little more than 10 years ago, and it has spread since then and jumped out to Washington State to the West Coast. So this is spread bat to bat. Bats are often in contact, they're social, they're swarming in the fall, going to cave and mine entrances, doing a lot of interaction. Also, when they go into that contaminated environment, they pick up mold just from being in the cave space. So even if they're a healthy bat, they get sick. And we can accidentally transfer this fungus around the landscape as humans who travel quickly and in great distance. So we need to be careful about what we're doing as biologists and cavers and other folks visiting caves. We're looking at a number of different ways to treat this and to help bats. And basically what I'll say is that we're not going to have a silver bullet. There's no magic cure that's going to be found. The treatments that we're looking at are in an attempt to reduce mortality. We're just trying to see fewer bats dying. We want more to survive, and we want to promote those survivors in any way we can. So currently we're working on a white nose vaccine with the National Wildlife Health Center in Madison. We're trialing that this winter in Wisconsin, so fingers crossed things will go well there. The other thing that I'll mention about treatments is that it's relatively easy to get things to work out under laboratory conditions where we can carefully control the situation. But I can't tell a bat to just come in and get their shots, you know, at an appointed time and date and place. So if we could do that, it would be a lot easier to help them. But we need to be sensitive to their natural cycle, and they're very sensitive to disturbance. So getting treatments to the bats without interfering or harming them is what we're interested in. This is some of our latest research. And basically, the ending message is that bats need your help, right? And there are a few really specific things that you can do to help them out. If you're visiting a cave, this is kind of an obscure one because most of us don't visit caves that often. But if you're visiting a cave, remember you could accidentally transfer that fungus. So if you go to visit a different cave, you've been to cave 1, you're going to cave number 2, don't wear the same clothes or shoes in between sites. Wear something totally different as you visit that second site. Keep out between October 1st and May 15th. Bats are hibernating. They can't handle disturbance, you know, from folks. They really need to conserve all the energy that they have, particularly if they're sick. Any one of you, if you like bats and have learned some new things, maybe today or through things that you've read, or bats that you've met, like the ones you'll meet today, if you like bats, share what you know, share that you like them, and help correct some misunderstandings that may still be out there. Put up a bat house. Obviously, that's always a good idea. We have plans for this bat house on the DNR website. So just go online and on our DNR website and search bat house. And I've got an example of the packet on the handout table up by the front. If you know of a place where bats are still roosting, and this is particularly important now this past summer and going into next summer, if you still know of bats that are surviving in the summertime, report that in. Even better yet, do a count. We really want to learn about the survivors and where they are and what we can do to help promote them. And we can't learn what's helpful to them until we know where the survivors are and how they're doing. So if you want to donate, we've got a couple of funds set up for long-term bat work in Wisconsin. And those are our websites. Okay, so we'll leave those up. And I'm going to turn all of our lights up so that you guys can see bats really clearly, because I'll bring out live bats for you to meet next. All right. And I'm going to have you hold off, if you can, on your question just till I'm starting to walk around. And then that'll be a really good time to ask questions as I'm showing the bats around. It'll take a little while to get around with the first bat in particular because she's tiny. So our first bat is called a big brown bat, but you know, she's not actually that big, right? She's a Wisconsin bat. So this is one of our native bat species. And she is a beetle specialist. So she loves to eat things like June bugs. And she might show you her teeth if you're lucky. She's got big sharp teeth because she's got to crunch through the carapace, the outer shell of the June bug. Hi, can you come out and visit? All right. So this is her. And she's just been taking a nap, but is hopefully excited to meet you. Yeah, showing you her teeth. Yeah, and so her eyes may be open or may be closed. The light does not bother her. But
So she's a hibernator, but she's not hibernating, so how does that work?
Yeah, so I'll put her into artificial hibernation, into a cool situation starting in January and through about March every year, just to help her mimic that natural pattern.
How does all of the blood rushing to her head when she's upside down not bother her?
Yeah, so when they're hanging upside down, doesn't blood rush to their head? Doesn't that bother them? They've got all sorts of special valves in their circulatory system that help keep the blood trapped and going in the right direction.
He's asleep?
She's at rest. Yeah, she's at rest. She's not asleep. Her eyes are open, you can see. Yeah, but she was sleeping when I took her out. Now she's awake. Sometimes she wiggles a little bit for us. But for the most part, bats, want to conserve energy. So most of their day is spent like this. They're just at rest, even if they're awake. It takes a lot of energy to fly. If you're a mammal, you burn lots and lots of calories doing that. So I know that she's at rest. Her body's cool because she's been at rest and sleeping. She'd start to get a little wiggly, so she's not just going to burst into activity. And in particular, this individual doesn't fly. She's got a wing injury, and that's why she's in captivity. Yeah.
She's not flying.
No. Rabies, yeah.
And that, what should we do if we see a bat in our umbrella or at the house or in our house?
Yeah. Okay, so the question is about rabies and bats. Bats, like other mammals, can carry rabies. And they do sometimes get in our living space, so it's something we need to be concerned about. The incidence in the wild is less than 0.5%. So almost no bats have rabies. But obviously we can't tell if a bat is sick just by looking at it. So if you're not sure if you had a bat encounter, like you woke up in a room and a bat was flying around the room, you need to talk to your healthcare provider about next steps. And oftentimes they will recommend that you get the post-exposure rabies vaccine if you can't capture the animal for testing. Okay. So if a bat is just, outside, if you encounter a bat somewhere during the daylight, it's not necessarily sick. We see all sorts of unusual bat activity, particularly in midsummer when the young of the year are learning to fly. We see bats, down low on the ground or showing up during the daylight hours. So it doesn't mean they're sick, but obviously, just like any wild animal, you'd never want to handle a bat. So if you get a bat in the living space, they sense airflow. So first you'll try opening a door or a window to allow that bat to leave on its own. And if it doesn't do that, you'll wait for it to land, watch where it goes, and then use the shoebox or ice cream bucket method, put it over the animal, slide cardboard underneath so you can avoid handling or touching to remove the animal from the house. Other questions? Yeah?
So that bat that had the 6-foot wing, the one wing.
Yeah.
How big is its body?
The body if it was hanging, you could see it hanging with Rob. So they hang down, almost 2 feet from tip of toes to the nose and the ears. And they weigh about a pound and a half. They're not that heavy.
Yeah, he does.
What's your question? You've been very patient. Thank you. Do you remember?
Oh, can the virus kill people?
Can the white nose fungus? The white nose fungus can't hurt people. It doesn't make people sick at all. In fact, the only problem with this fungus is that it loves to grow on the skin of bats. So it causes damage in their skin by growing into their skin. Other questions? Yeah? What was that? Oh, on this bat, I'm not sure how the wing got injured. It was found and turned into a wildlife rehabilitator and then couldn't be released. So she's been with us for about 5 years as an education animal. So we know she's at least 5 years old, but Once they grow into adulthood in that first year of their life, after they've been a juvenile and grown into an adult, we can't tell how old they are.
Look at that little thing. Take a picture so Vera can see it too. Look at those tiny little ears. Yeah.
All right. Yeah.
Oh, I'm sorry. I can move my...
Go for it.
Could there be a way to stop the fungus from reproducing? I mean, the fungus.
Is there a way to stop the fungus from reproducing? Yes, in fact, they're looking at some folks out east and down south are trialing a compound that makes the fungus think that it's really dry, where it stops producing fungal spores, which is how fungus reproduces. It's like the seed of the fungus. So that would, if that works, that would involve going in and like spraying down the inside of a cave or a mine in the summertime. And we wouldn't do that with a cave because caves have really sensitive ecosystems, and most of the cave environment is fungi, right? They're molds. But we could potentially do that in a mine. Now the issue there is that we'd have to go into almost every mine every summer and try to kill off or fool this fungus to treat the site. So anything that we do, we want to make sure that it's sustainable, or as sustainable as possible, meaning not a lot of impact on the bat or the site, and as little work and money for people as possible. So, yeah.
Picking from Europe and the places, what do they do?
Well, so by the time this caused a problem here, it was causing a problem, and then we started looking at where it originated from, went to Europe and Asia, realized it's already widespread in every site in Europe and Asia, and it's not causing massive mortality there like it is here. European bat populations compared to what we had here are very low and have always been that way. So as far as anyone knows, it's been there, forever, at least before anybody noticed or cared. So we know that this fungus evolved and separated from its closest fungal relatives, its cousins, about 20 million years ago. So it's really highly adapted to caves and bats. So no telling where it, kind of originated, but eventually genetics will clue us into regionally sort of where that story began. Yeah.
How do they clean themselves? Like cats licking?
Yeah. So like a lot of mammals, they just spend a lot of time, licking, grooming their pelage, their coat, and their wings, and their hands.
Do they clean each other?
Mutual grooming is more dependent on species. So we were hoping that our little brown bats were mutual groomers, because we know, for example, that vampire bats are mutual groomers. They do a lot of sharing of grooming activity. And one of the ways that folks in South America kill off vampire bat colonies, which unfortunately is something that happens a lot, is to deliver a vampiricide, a poison, in a gel. And if you just put it on a couple of bats, those bats spread it through the colony and the colony dies off. Well, this is a good idea in the sense that we thought, well, we can use that same technique, the gel, to deliver a vaccine for good. The problem is when we were testing that gel spread in a colony, the little browns here, so different species, are only grooming really themselves and not each other. So when we are thinking about delivering our vaccine in a gel, we're thinking we'll have to spread it inside a bat house where all of the bats crawl over it and then end up ingesting it. So that'll be the trick with the vaccine delivery, is getting that next stage or next step to work. And that's tricky. That's where things get tricky. I'll show you this too. These are not live bats, but I do have some little brown bats here for size comparison. You just saw the big brown. These are little browns, and then we've got some other species. So these will be up front, and if you'd like, you'll be able to come up close and see them and visit. But to wrap up today, I'll bring out the fruit bat. And this is a bat that lives native in Africa, okay? So it can't survive in North America. It was born in a zoo, born in captivity, about 18 years ago. And his name is Rafiki, and he's called a straw-colored flying fox, or straw-colored fruit bat. So flying fox is just another name for these mega bats. This is the largest bat on the African continent, and if you've ever seen like National Geographic specials with millions of bats flying across Africa, that's typically the species that you're seeing in migration. He really will appreciate it if you guys, just like you're doing, are nice and still and you stay in your seats as we come by. And then also if we keep our voices nice and quiet, and you guys have done an excellent job being patient, waiting to meet him. But he's not a pet, so we like to just respect his need for stillness and a little bit of quiet. Hi, buddy. You might notice him, I've got to unhook toes. That always takes a minute. Okay. So you might notice as we walk around, he's used to climbing in trees. So he'll sometimes reach out with his thumbs or with his mouth, and he'll kind of grab onto me like I'm a tree. So he's not being aggressive if you see him open his mouth or grab. He's just climbing like he would in the wild. So he only eats fruit. In captivity, it's a lot of bananas and melon. He also really likes Honeycrisp apples. He doesn't like Red Delicious. He's got to have the sweet ones. Yeah, right? Don't we all? Other questions? Yeah?
How old is he?
He's 18 years old. Yep, no driver's license yet for him though. So this species will live maybe 20 or 25 years in captivity.
Is he also going to get a hibernation mode?
Yeah, he's not a hibernator. Like a lot of bats, he can use torpor for short periods of time, but he's not a bat that goes into extended torpor for weeks or months at a time. So he wouldn't cool down his body for an extended period.
How are you getting him not to take off?
Well, so why isn't he flying around? Why isn't he flapping? Again, he's comfortable with me. He's at rest. He's been doing this his whole life, visiting with folks. But he is also non-flighted. So when he was born, he lived in a really overcrowded cage for about 2 years before that group was thinned. So he didn't develop the skill of flight, unfortunately. So he'll maybe flap for us. He'll maybe show us his wings. But yeah, he's not going to just take off or anything like that. He spends a lot of time really grabbing and climbing with his thumbs, just like you would notice with a primate. You know, he uses all four limbs to climb around. And he's got a really sensitive nose, really sensitive ears. So he likes getting out, and sniffing people, like the people with the mango body wash, probably, right? The banana perfume. But you'll notice his ears are just wiggly, and he's always paying attention. Let's see, I'm gonna go over here. Other questions? Yeah.
You mentioned that what really does the bats in is that they starve to death because of this fungus. Does leaving food supplies over winter in the cave help at all?
Yeah, so it's kind of like that first thing is, well, can't we just feed them if they're starving to death? Bats are hunting on the wing, so they're hunting flying insects as opposed to, mealworms in a dish like they'd eat in captivity. And they have to be trained to do that. And again, our search is for something really sustainable. So feeding millions of bats nationwide isn't, at sites or having to hand feed or train a bat isn't something that's sustainable. So the focus is on vaccines and environmental treatments. Yes? You have a question? Or are you just stretching? You do? What does this bat eat? Only fruit. So some of his favorite things to eat are bananas, but also cantaloupe and watermelon, and he loves grapes too. So, do you have anything in common with him? Do you like any of those fruits?
I like strawberries.
You like strawberries. He's never actually eaten strawberries because that's a berry that would grow on the ground. So we only feed him fruits that grow on trees. Yeah. Do you have a question or are you stretching? Yes, what's your question? How big is he? He weighs, in my hand, he weighs about as much as a can of soda would weigh. So he's about 13 ounces, just a little more than a can. And his wingspan is about 30 inches. Okay, so like 2.5 feet when he stretches his wings out. Yeah, he's really, I mean, they're really intelligent. They really are very social. And they live a long time. So I always figure it's like, you know, you either learn as you age, or in order to survive a long time, you have to be pretty intelligent. So, yeah. Stand right there. He's gonna go up on his handy tree here. Yeah. Yes, what's your question? Where did we find him? Well, he was born in a zoo with a colony of other straw-colored fruit bats. And then because the colony was too big, some of those bats went to a group in Michigan called the Organization for Bat Conservation, and that's an education group. And he lived there for most of his life, and then he came to us for our education programs in 2011. It's really hard not to just want to rip I know, I want yeah, they're like velvet. I wish I could let everybody touch, just because they're really, really soft. Beautiful. Yeah.
Yeah. So the mammary glands are like on a human then? There's
Yep. Yep, 2 mammary glands. Although some species will have more, and so some species will sometimes have routinely twins or triplets, like our eastern red bats will often have triplets. But typically it's just one pup when we speak generically about bats. Yeah?
Are you going to feed him the banana?
Yes, he's going to get, when he goes back to his little travel kennel, he's going to get a little banana treat. So what you'll notice is as I get back close to the kennel, he sometimes gets a little excited. He'll like stretch his wings out. He's already he knows we've kind of done the rounds already, and we're up to the front of the room, and so he's getting a little more excited. Yeah, yeah, he's like Velcro. His little little toenails and little thumbnails are really sticky. So that's why I've got the gloves on too. They're really sharp, very sharp little nails, like a little kitten's claws. So when I put him away, what you'll notice is that he'll kind of climb himself into his little kennel, just like you've noticed he wants to go up higher on my arm. And he's, again, kind of primate-like in the way that he climbs. He'll just take himself in. Okay, yeah, now he gets a treat, and you are welcome to come up and visit with him, but just please stay about an arm's length away to give him his space. And thanks very much, everybody, for your attention and for coming down today. What was that? How long does it live? This species will go 20 or 25 years in captivity. Yeah, and in the wild, a little less.
Really?
But if you can count